Merry-go-round. We've all been on those. You sit on it there and you go around and around. Okay? This one here, we're going to put it as a plate. And we're going to put a rock on that plate. Okay? And then we're going to spin the part around. Okay? So now we've got a couple of questions we've got to figure out right away. First of all, gravity. Yes, there is gravity. It's going down. Is it on a surface? Well, yeah, we just said it was on a plate. So yes, it's on a surface. Is there friction? Well, let's think. If that spins, is that rock going to stay right there? Well, it wants to go this way, right? Because an object in motion stays in motion in a direction constantly. Okay, Newton's first law. So unless there's something to stop it, it's going to continue to go straight. So it's going to go in a circuit. So yes, there's friction. Is there a push or a pull? Is the rock attached to anything, a string or anything? The answer is no. Is it going in a circle? The answer is yes. And where's the centripetal action? It's going to be going toward the middle. We're just going to say here it's acceleration in this direction, and that's the positive. All right? So we have the parts. All right, so we have gravity. So here is our free body diagram. We have force of gravity. We're on a surface, so therefore we have to have a force normal going in the opposite direction. We have friction. Well, which way is the friction going? Well, the friction is actually working as our centripetal action, which is our force of friction going in that way. Okay? So is the rock going up or down? So if it's not going up or down, then these two things have to be the same, right? Because it's not moving in the y-axis. It's staying in the same spot. So therefore, the only force we've got to deal with here is the force of friction. So our formula, again, is going to be just like the last one. Force of friction is MAC. Okay, I forgot to write it. Force net equals MAC. Because we want to keep putting Newton's second law in here because we're kind of tired of it. Okay, so now we have 1, 2, 3, 4 variables. If we know 3 out of the 4, we can solve the problem. And we'll do something like that with one of our problems. Okay, our fourth one and our final one that we're going to do is a Ferris wheel. We've all been on a Ferris wheel before. You know, there's a plate there or a seat or whatever else, and that's going to move around in a direction like that. And this is going to stay square as it moves so that you don't fall out. Okay, so you're moving around. Okay, so let's start here. We're right up here at the very top, and there's a plate right up there at the very top that someone is sitting on. All right, so is there gravity? Well, of course, yes, there is gravity. Are we on a surface? Well, we're on the chair, so yes, we're on a surface. Okay, is there friction? There's going to be some friction here in the center, but that's not going to be anything that we're going to worry about. Is there a push or a pull? You know, this is one where it kind of goes back and forth. You know, is there a push? Isn't there a push? You know, there really isn't anything that's tying that sheet, that chair to move around, that's forcing it to stay there. So we're going to say no on the push and the pull. Is it going in a circle? Absolutely. Is it going in a direction? So our acceleration is in this direction, so it's this way, and that's the positive number. Okay, so acceleration is in the positive direction there. Okay, so now our free body diagram, we have gravity. F of G. We have a surface, so therefore we have to have a force going this way, F of N. We've got no force going this way, and we've got no push or pull. Okay, so now let's see. We're up here at the top, so we've got to look at this here really quick here and say that F of G has got to be greater than f of g is greater than f of n, oh, wait a minute, force net equals ma centripetal. Okay, so our net forces is this force here has got to be greater than that force going in that direction. Okay, because we're moving. So that has to be the case. So it's minus there, and then we're going to get MAC. So if our force of gravity is greater than when we're at the top there, our force normal is less. So we're going to be nice and lighter at the top than at the bottom. The bottom we're going to take and put f of n, which is going in the same direction, f of g, which is going in the same direction. So those are going to be added. So that's going to be a heavier, and you're going to weigh more. This is when we get to our term of g forces that we had in one of our problems before. There it is, the g forces. Gravity times. Well, we're going to be adding to it, so it's going to be making it go in that way. But let's just deal with our problem at the top. And at the top of the Ferris wheel, we would be f of g minus f of n equals ma centripetal. That concludes our examples for you to look at. We'll be going back to these in some sample problems in our next video.